The universe is dying, not eventually, not in some abstract philosophical sense. It is dying right now, in every direction, at every scale. And in 2026, we got a more precise measurement of exactly how fast. For most of scientific history, the death of the universe was a distant abstraction. Something so far away in time, it barely qualified as a concern. The stars would burn out. The galaxies would go dark. But the timescales were so enormous, trillions upon trillions of years, that it felt safely theoretical, a problem for another era, a fact too remote to feel real. Then the James Webb Space Telescope sent back data that didn't match the models. Webb's observations of distant supernovae, exploding stars used as standard cosmic distance markers, combined with updated dark energy measurements, produced a revised expansion rate for the universe. The number came back higher than expected. The universe is not just expanding, it is accelerating, and the acceleration is faster than our previous best estimates suggested. The gap between old models and new data is not a rounding error. It is a significant revision of the timeline for how this all ends. This matters because of what drives the death of the universe: dark energy. The invisible force woven into the fabric of space itself, pushing everything apart, stretching the distances between galaxies, between stars, between every particle. As expansion accelerates, structures become harder to maintain. Galaxy clusters dissolve. Star formation slows as the raw material for new stars, the vast cold gas clouds and nebulae that seed them, gets pulled thinner and thinner across a growing void until nothing new can ignite anywhere. The last stars to survive will be red dwarfs. Small, dim, burning hydrogen, so slowly and so efficiently, they will outlast everything else by trillions of years. Long after the Milky Way has gone completely dark, long after our sun has swelled, expanded, and cooled to a cold cinder, the red dwarfs will still be burning, faint, alone, in a universe with nothing left around them. But they will go out too. Every one of them. One by one, over timescales the human mind cannot hold. Every source of light in the observable universe will exhaust its fuel and go cold. After the stars, black holes, the last surviving structures in the universe. Slowly evaporating through a quantum process called Hawking radiation, leaking energy so gradually that the largest ones will take longer to vanish than the current age of the universe multiplied by itself more times than there are atoms in existence. And then nothing, no light, no heat, no structure, just an endlessly expanding void of cold particles drifting forever apart in permanent darkness. The 2026 data did not change this story. It sharpened it, made the timeline more precise, the trajectory more certain. The universe had a beginning. It will have an end, and we are somewhere in the middle, on a small, warm rock, briefly lit, watching the clock run down